People, good afternoon. So you guys have written a test yesterday, you got the test back, so let's go through the memo quickly. People, this is how you get 20 marks. No? Not like what you guys have written, okay? Class test 2, term 2, here we go. Oops. Girlfriend, stop now. We had now a nice 10 minutes to make jokes and stuff. Now we're busy with work. You can't distinguish the difference. So properly, take a different color pen out and write the memo down. Okay? The question says determine the values of x, y, and z in the following diagram. Give a reason for each step. We are also told that AB is parallel. AB is parallel to DA. If lines are parallel, we know we can use alternate corresponding and co-interior angles. Not so. So, for alternate angles, those angles are alternate. So that angle will be equal to that angle. Not so? Yes, sir. So in pursuit of calculating x, I can then go with sum of triangles. You all agree with that? So let's go with that. We're going to firstly say that angle B is going to be 50 degrees. So I must first say angle B equals 50 degrees. Why? Because of alternate angles. With DE being parallel to AB. We say corresponding alternate or co-interior, you must say which lengths, which sides of the parallel sides. We'll look over that. Now what can we do? We can go with sum of triangles now. Not so. So we say now that x plus 50 plus 48 equals 180. Why? Sum of triangles in this triangle ABC. So 48 plus 50 is going to give you 98, not so? So x is then equal to 180 minus 98, which is 82 degrees. Okay? Yes. Let's carry on with our lives. One 1.2. So in 1.2 for 6 marks, we can calculate x first. Not so? Yes. How? Angles on a straight line. So x is equal to 110. Straight line. Not 110, no. Yes, I know. Sorry, mistake. X plus 110 equals 180. So x is equal to 70. Not so? So to calculate y, the value of y, we can see that the exterior angle is equal to the sum of the two interior opposites. Not so? Or I could have gone with angles on the straight line, but then I'm shorting that angle B. You all understand that? So that means to say, that's going to be my better bit. Exterior angle is equal to the sum of two interior opposites. Not so? But we don't have the value of angle P. But what is angle P equal to? You see, with that length being equal, that angles they are equal. Okay? So we're going to say angle P is equal to 70. Why? Angles opposite equal sides. Okay? So there's 70. So y is equal to 70 plus 70. Or 70 times 2. Or straight 140. Why? Because that's the exterior angle of triangle. Dot, dot, dot. And it's triangle PTS. Okay. Bianca, you might look here, Michael. Don't forget tomorrow's the photo day. No? See Bianca smiling so big. You ready for the photo tomorrow? Don't forget, no? Winter uniform. Right, you guys ready for Z? Yes. How are we going to calculate Z? The interior angles of a quad adds up to 360. Can you see that? So let's go. It's 110 plus a half x. But what is x? 70 plus z plus 140 equals 360. The reason? Interior angles of quad.
Sir?
Yes.
TRQ is what?
TQ.
TRQ.
TRQ is, yes, absolutely. What's a quad? What is a quad? Four sides, enclosed shape. Is made up of four sides, edges. If it is a quad, the interior angles of a quad adds up to 360. Okay. But this was an easier way. Sum of triangles. P, R, Q is also a triangle. So I could have said a half times 70 plus Z plus 70 is equal to 180, sum of triangles. That's actually easier. Is that what you use? Nice. I like it. People, geometry is beautiful.
Yes.
Huh? Where? Everywhere. But Z equals 360 minus. Now, that's 110 plus half times 70 was 35. So it's 110 plus 35 plus 140. So it's a 5, 8, 285. So it's minus 360. And 360 minus 285. So it's Z. Carry. Take away 2, 1, 1, 5, 7, not 7. Yeah, 7, 75. Is that correct? There we go. So easy. No? People, as I told you before, geometry, you're not going to figure it out in the exam. This is going to take a lot of practice. Okay? You guys must sit down, and you guys don't have that time, no? Now we're going to TikTok and you don't TikTok anymore. You picked up. You broke the phone while TikTok. No. Right, let's look at number 2. In number 2 we are told, that ABCD is a parallelogram. People in the parallelogram, 4 things comes to mind. What comes to mind? Good start, yes. 2 pairs of opposite sides, equal. 2 pairs of opposite angles, equal. 2 pairs of opposite sides, parallel. Diagonals, not 2 lines, diagonals bisect each other. So, here you're going to say x is equal to 118. Y is equal to 62. For both reasons, you can't write it like I'm writing it. For each one you must write. 2 pairs of opposite sides. 2 pairs of opposite angles. If you're talking about angles here, you can't say sides here. 2 pairs of opposite angles equal. In parallel, yes, in a parallel. Nice. You are right for both. No? Then AB is equal to DC which is equal to 32. That length is equal to that. And AD is equal to 16 centimeters. A millimeter, sorry. For both, you should have written 2 pairs of opposite sides equal in form. Not the Mickey Mouse you people wrote. Yes. Right, let's move on with the lives. Last one. Number 4. In number 4 we are told BEC is a kite. If that's a kite, what do we know? 5 things. One pair of opposite angles are equal. So you're reading well. Diagonals by 6 and 90. Diagonals cut each other at 90 degrees. 2 pairs of adjacent sides equal. You almost got the chocolate by see you reading. Now the next one. One diagonal bisect each vertex angle. One diagonal bisect the other. In a kite. So what's wrong with that? So A, B, C, right, kite. Then we are told that B, F, E, A, the parallelogram. 4 things comes to mind. Which one are we going to use here? Opposite angles are equal. 2 pairs of opposite angles are equal in the parallelogram. So here's your 50. Can you see that? This is a kite. So that is 90. You told me all the rules. But you can't apply it. Why? Because I don't practice it. That's the only reason why. And then I can go with sum of triangles here. Can you see that, people? Easy. I'm upset it's so easy now. Right, now listen, we can't just say A. Can I just say A? No. Why not? More than one angle at A. So what must I say? B, A, O, or B, A, E, or E, A, B, or O, E. There's so many options. But you people say right A. So you got A, C, and not E, A, B. Yes?
What if in the exam?
Shh. Listen. Yes?
What if in the exam we write that and 1 and 2?
No problem. But then you must write it in your answer book. So you must read through this in your answer book and then you make it a 1 and a 2. You can't do it on a question paper. I don't mark question papers. Because I mark the script. Put your mouse on. Right, here we go. So, what's your reason here? 2 pairs of opposite angles equal in parallelogram. Not so. So 50 lie here. You got it, Lisa Kanya? You've been quiet for the past couple of lessons. The people online is asking me what's going on with Lisa Kanya. She's not asking any questions any longer. Are you upset with me? Good, keep it that way. Alright. What can I say here after? 90. BOA? 90. Why? Diagonal? Perpendicular? In kite. Over diagonals? They don't bisect each other. One diagonal bisects the other. Okay? Diagonals perpendicular in a kite. One more. How do we calculate y? Sum of triangles. So y plus 90 plus 50 equals 180. Why? Sum of triangles. And this is triangle BOA. So therefore y is equal to 180 minus 90 which is 90 minus 50 which is 40. Okay. People, practice. Don't forget about the 10th of May when you're writing your cycle test. Sorry? Next week. Oh, next week. Don't forget, the topics you're writing on is geometry,
Algebra.
equations, no? And what else? Only on those two. Congruency, yes. So I must give you a test tomorrow on congruency, yes. Theorem of Pythagoras. There we go. Pythagoras. She wants a question on the theorem of Pythagoras. So you'll get one. Alright. So listen, tomorrow's test, we'll put those topics in. Okay. Because listen, I don't want to be when I mark your paper, listen. Show me. Who can answer that question? You could have most told her the answer to that question. Who asked? Pythagoras.
Yes, sir.
No. Listen, easy sums in Pythagoras. Slowly, no? Right, listen. At this point in our lives, we had homework on this, no?
Yes, sir.
Alright, let's do this. I said I was going to do the odd numbers and then I'm going to send you a photo of the written memo. Alright, girlfriend, turn around. Right, we are on exercise 3 on page 151. We are told if AB is equal to CD. And as you can see in the diagram, it's given equal. Can you see? Bless you. We're getting there. Okay. People, so the question says, you must prove that AC is equal to BD. AC is equal to BD. So, how are we going to prove that AC is equal to BD? We'll prove it by letting the two triangles be congruent to each other. Not so. If the two triangles are congruent to each other, its corresponding angles and the corresponding sides will be. Not so. So, we're going to prove congruency. So let's go with it. In triangle, A, B, C, and triangle. Let's try and get the order from the beginning right. D, so you got D, C, B. D, C, B. Right, where do we start? What's the first thing we can say about the two triangles? Parallel. Parallel. AB, give me a shock. Is equal to DC. Why? Given. Who is saying parallel all the time? Mary, you take me for a fool? Can I say just angle B? No. Not O. It's a D. So it's D, A, B, C. So it's A, B, C is equal to D, C, B. Why? Why is it equal? Given. One more. DCB, D. Yes, DCB.
BC is a common angle.
What? BC. Is this a BC? Common side. Lovely. Look here. If you talk to her, she's not going to look at me. Okay, you're more interesting than me. You see? So look here. What do you say about BC? BC is a common side. You see, BC is in both triangles. Okay. So BC, you write the BC, here common side. So what can we conclude? Therefore, triangle ABC is congruent to triangle DCB. Why? We use a side, an angle and a side. Not so? So it's going to be, I just told you now, Sisona. Side, an angle and a side. So why are you saying angle, angle, side? You're starting your nonsense again. I hope not. You think it's a joke? Yes.
So why isn't it just angle B? Because it's the whole angle.
You see, you can't just say angle B because there's this angle at B. There's that angle at B. And there's our angle at B. Okay, so if you are going to say only B, I'm going to penalize you for it. Okay? Because at the end of grade 12, you don't know who's marking your grade 12 paper. So rather do things properly from the beginning. You understand? So write the proper thing. Have I answered the question? No. So now I can conclude. Therefore, AC is equal to BD or DB. Why? Because we have proven that triangle ABC is congruent to triangle DCB. Okay?
There's 4 lines.
3. Where do you see 4?
B.
Where? This is 3.
No,
3
no,
lines.
no,
The big one.
the blue one.
Oh, blue. Yeah? It's 4. You say it's 4. Okay, it's 4. My mistake, no? It must be 3. So I'll put 3 for it, just for you, no? Or nobody's mommy coming here and complaining. You don't give my child a hearing. No? Right, you guys got it? Right. Don't write 4 lines. You will get it wrong if you write 4 lines. Okay? I don't know what you think. Who's busy with you and your maths? Right. People, number 11. Number 11 says use the diagram to prove that AB is equal to, make this a bit smaller. Assalamu alaikum. I was waiting for you period 4. This period 5. Yeah, come on. Alright, minute. Huh? Right, listen. Using the diagram, prove that AB is equal to AD. So we must prove that this length here is equal to that length. So how do you think we're going to prove that? By using? Pythagoras. Well done. So, here we go. In triangle ABC and triangle, let's go in the right order here. ABC will correspond to ADC. What can I say about the 2 triangles? First things first. BC is equal to CT. Why? Equals 90. Yeah, give it. Yeah, give me a chance to make a mistake. Alright, give it. What else? Yes. Well done. AC is a common side. One more. If I can prove angle D is 90, I've done the job. Not so? So I'm going to go with sum of triangles. But I first need that. And then I can, exterior angles equal sum of 2 interior angles. Can you see that? So we first need C1. How are you going to calculate C1? Angles on the side. Absolutely correct. So C1 plus 117 is equal to 180. Angles on a straight line. So angle C1 is equal to 180 minus 117, which is 63. Alright. Now what? 153 degrees equals angle D plus 63 degrees. Why? Exterior angle of triangle. Dot dot dot. And it's triangle ADC. So angle D is equal to 153 minus 63. 90 degrees. Hang on. Hang on. Angle D is equal to angle B equal to 90. There's the third one. Can you see that? The bullet says 1, 2, 3. The third thing here. You always see me write these bullet points. I shouldn't have drawn it like it. Write the bullet points when there's a lot of calculations involved. Otherwise, in the past, when it was straightforward, you never saw me put bullets there. Can you see that? Right. But however, in this case here, there's bullet points because there's a couple of calculations involved. Are you all okay with that? Right. But they haven't answered, they haven't even concluded. So what was I say here? Therefore, triangle ABC is congruent to triangle ADC. Why? Who can tell what's the case of congruency here? Side angle side. Why RHS? We use 90 degrees and we use the hypotenuse. Not O, it's a D. No? Or B. Or HS. Listen, the people that's talking in the background. Stop it, please. Okay. So if you feel you can do a better job here, let me know. I'll give you a couple of sums to do on the board. Okay? But you can't be talking in the background. People, number 14, I think number 13, I skipped. And I'm doing number 14 because number 14 is a bit different to what the sums that we currently do. Okay? So O and P are centers of the two circles, which intersect at P and Q, which is these points here. Then you have the first question says prove that. You must prove that QPO is equal to RPO. How can we do that? We can do that by using Pythagoras. Not Pythagoras. A congruency. We got the side no, we can't use congruency. Why? Because we will be able to say that is equal to that. That's your common side. Then we either need a side or an angle. If you're going with the angle, it must be the included angle. But that's the angle I'm going to prove anyway. They asked me to prove, so I can't use that. We're going to go with the fact that this is a kite. You'll see now why. A kite. So, in this shape here, in quad QP or O, what can we say? We know that QP is equal to PR. Why is that the case? Remember, if I take that circle out, that smaller circle, that was P. Why is QP equal PR? Why is QP equal to PR? Yes? Lengths, not angles. The two lenses. Yes, it is absolutely the same, but why? No? Daskin? Leave your hand, don't cut your hand. Why is QP equal to PR? You don't know? Anybody? What shape is that? The on the side. Does it say? A triangle. That's a triangle. It's a circle. So in a circle, from center to circumference is called your radius. The radius of a circle. So if you got a circle, from center to circumference is your radius. Center to circumference is your radius. Anyway, from this point to the circumference is your radius. Will always be the same length. You guys understand? So that's your radius of a circle. So you can say that QP is equal to PRY because it's your radius. That's all. Then we know that QO and OR. QO is equal to OR. Why? Also your radius. But that's the radius of the different circle. That's all. Why do I put one stroke here and two strokes here? They're not the same length. Okay? But these two are the same. PQ and PR, whilst QO and OR is the same. Make sense? Right. Now, remember, if something's a kite, there are 5 properties. The one property says 2 pairs of adjacent sides are equal. Have we not just proven that now? Not so? We just proven that now. So we say, once we got this, therefore, QPRO is a kite. Why is this a kite? Because 2 pairs of adjacent sides equal. Now here, we don't say in kite. Why? Because we're proving it is a kite. You understand the difference? So you say QPRO is a kite. Why? 2 pairs of adjacent sides are equal. Now since we have proven now that this is a kite, all properties of a kite is now evident here. Now just go take one step back. When this was a kite, what were the properties? 2 pairs of adjacent sides equal. We know that. We use that. What else? 1 pair of opposite angles are equal. What else? Diagonals. One diagonal bisect the other. What else? 90 degrees. The one I want you guys to say you're not saying. Last one.
The dot.
Dot. The diagonal bisect the vertex angle. Can you see that? The diagonal, now you see this diagonal here, bisect this vertex angle. There's your dot. Can you see that, people? So let's go with that. So we now say, therefore, QPT or QPO is equal to RPO. Why? Because one diagonal bisect the vertex angle in a kite. Because now it's a kite. Can you see that, people? And that is now coming after our claim that it's a kite. Okay? Let's go with B. Prove that OP bisect QR at T. So you must prove that is equal. But that will be equal. Why? Because that's a kite. One diagonal bisect the other. But what they actually wanted you to do have used was congruency. Okay? So in the exam, if they specify, like here they didn't specify. So I could have just said OT or QT is equal to TR. Why? Because I one diagonal bisect the other in kite. That would have been suffice. But what they wanted you to do have used was congruency. Okay? So I'm going to do the congruency so that you can see how we using it. So it's going to be in triangle QPT and triangle RPT. What can we say? You see, but some of you would ask, why am I not using that triangle? No? Because if you're going to use that triangle, I'm not picking up QT and TR. Can you see that? So that's not going to help me in proving that thing. Alright, so what can we say about these two triangles that we're working in? We already see that QP is equal to PR. Why? No, it's not given. It's either proven or we can say again radius. Can you see that, people? You can either name the reason again or you can say proven. Why proven? Because we said it before. Can you see that? What else can we say? We can know that QPT is equal to RPT. Why is that the case? Proven. As you can see, we have proven it here already. Can you see that, people? And the last one, TP is equal to TP. Okay, so TP is a common side. TP is a common side. So here we got side angle side. So we can say, therefore triangle QPT is congruent to triangle RPT. Why? Side angle side. So therefore QT is equal to TR. Why? Yeah, as you can see here, QT is equal to RT. Because triangle QPT is similar, congruent to triangle RPT. Okay? And there we go. Bisecting means to say that it cuts it in half. So that basically brings us to the end of this chapter. Is that correct? Oops. Yes? Sorry? I don't know what you're saying. Yes? If not, why not? Huh? A sum like this is worth probably 8 marks. I will give you 4 on the sum and 4 on the sum. Yeah, about 4 marks. This only if you wanted, you would go study it. But if you don't want it, then you just leave it out. Alright, you guys okay with that? So that brings us to the end of similarity and congruency from the study and master textbook. Then yesterday I gave you homework out of the other textbook. No?
Yes, sir.
I mean out of the workbook. Okay, so I'm going to stop this video and start the other video. Okay.